Hey everyone, welcome back to the channel. So today we are diving into a topic that every developer faces sooner or later. So today we'll be discussing about refactoring legacy code. So you know the scary jungle of don't touch it or break code that you might have heard everywhere while you're working on a large application base especially. So if you have ever opened a file and immediately felt the urge to close it, then this video is especially for you. So, what is meant by legacy code? Let's get to that. So, legacy code doesn't just mean old code. It usually refers to code that doesn't have test cases and it's hard to understand, read and understand, and has lots of duplication. And worst of all, there will be no documentation to actually understand what is going on there. Or the documentation might be there, but it might not be updated with the latest code base which we have. So sometimes that code works, but no one really knows how it works or why it works. So that's the most scary part of dealing with legacy code. So before you touch anything, so what we have to do is we have to basically understand what the code does. So how we can understand what the code does? We can use the debugger or debugging tools to understand the flow of the code and use the log input and output to understand where the code flow comes or what are the values of the what are the state variables of that particular code at a particular point in time. So that's one way to know it. So then what we can do is we can write test cases first, even simpler ones, to understand what is the behavior of the code, to understand the behavior of the code. So it helps us to snapshot the current behavior, and if you break something you will definitely know that something has broken if you have modifying that code. You have some test cases to cover that particular scenario. So the other thing that you can do is you can talk to the original authors who wrote it, but under the condition that it will still exist. So refactoring without test is like defusing a bomb blindfolded. So don't do it at any cost. So please understand what you are trying to do, what you are trying to refactor or trying to modify or trying to add a feature to the existing code. First understand what the actual code does and what all its impact will going to be. So let's try to dig deep on certain cases. I will just go through certain cases where we have to do some refactoring, or there are some cases in our code that we will see that it is very hard to understand. Let's go into those examples. So I have noted down quite a few scenarios. Of course, these are very simple examples that I'm going to explain here. This might be very overcomplicated in the actual code base, but you will get a hint of what I'm talking about here. So here, what I'm trying to do is, if you try to read this particular process API, it's trying to do some validation check using an if condition and trying to do some action based on that particular if condition. If it is true, it performs some action. So it's pretty difficult for a new programmer or developer to understand what this if condition it actually does. So it checks the user state, it checks the user email and some email details of that particular email. So in the first case, user has to go through each of these conditions which is appended to understand really what this actually means. It is trying to check whether it is a valid user or not, and if the email ID is valid or not. That's what at the end it checks. So if there is a way that if we refactor the process API in such a manner that if we have a utility API or a helper API like is valid email user, then the user At first glance itself, we will get to know what this particular API does or what this particular API returns. So he doesn't need to go into the detail of this API implementation. He just need to skim it through. With this helps to save a lot of time here. So that's the first thing that we can do. If you see any particular this kind of an example in your application code base, better to refactor them and introduce small helper APIs so that it will later on it will be easier for you and the developer to understand what this particular code piece of code meant in that first case. The other common pattern that we observe in the legacy code bases is uh, duplication. There will be a lot of code duplication which will be there. So first, let's understand how this particular duplication went in. It might not be an intentional. For no developer will try to introduce a particular code duplication intentionally. So what could be happening here is there might be a use case or there might be a requirement that if the order status is pending, you send a reminder with the customer email for the customer uh, with the customer email as a context. So that might be the requirement in the first case. So later on, at a later stage, the requirement came that the orders is pending. There will be a lot of code in between. So it doesn't mean that these two conditions are close together. There are a lot of code in between, and the some other developer at a later point in time got the requirement that if the order status is pending, then you log a reminder with the log of that particular order ID. So he might not be aware that this particular condition exists in the at the beginning of the code. So he might have missed this particular condition altogether. That might be the reason that there is code duplication which went into the code base. So this is not actually the fault of the developer, but it actually the way the code is structured or the code is initially written in such a manner that uh, that particular developer who has written first might not have imagined or might not have thought of the future cases of expansion of this code base or future requirements which might come in at a later point in time. So what we can do is if you are trying to write a particular uh, case like this, so better we actually check, we introduce a helper API to check the status of the order. So here the code duplication is checking the order status twice. So once here and once here. So this might get very complicated if it is a multi-threaded scenario. So what we can do is introduce a single API which checks for the order status everywhere throughout your application code base. So you can only rely on this particular API to determine whether your order is pending or not. So instead of going ahead and modifying every piece of code where we are checking this particular state and then do these actions. So if you see any such pieces of code, you can go ahead and safely do this particular modification. So this will be very helpful for the end for you as well in the future if you have to modify this particular piece of code. So next scenario that can come in legacy code base is there might be long method, a method whose number of lines might be exceeding. Even I have seen lines of code, 600, 700 lines of code in a particular function. And that is too much of code which is belonging to that particular function. So here I have taken a kind of a miniature example of that. Here what this generate report API does is it tries to fetch some data and tries to process the data and it tries to export that particular data after this processing. So it tries to perform three different actions here within a same API. So generate report, if you just read through what we think, what as a layman will think, we will think that the API generates some kind of a report. It doesn't do any data modification. That's what a layman thinks. But here, if you see, it is trying to fetch the data, it's trying to process the data, it's trying to modify the data, and it's trying to export the data. And here, it is trying to create a report here at the end. So, even though the API says that it is a generate report, it does many more things than that. So, it actually violates the single responsibility principle that you might have already heard, or in one of the it is one of the solid principles out there. So what we can do? So this is a long API. What we can do is we can split this API into three different blocks, which does three different actual actions. Like export report only does export, process data will only do processing, and fetch data will only do fetching. And there will be an API. We have to rename this API called some custom process. If you rename this API called custom process, then what this API will do is it performs three different actions, but we have abstracted all these things with a separate API. So this is not the correct example per se, but in the object-oriented scenario, if you're dealing with objects, this actually makes sense. So if you have different classes to deal with fetching, you have different classes to deal with processing, and if you have different classes which deals with the export, then have a common API, and it will only call that common method, but it will go to different objects based on the scenario. The other major thing that we will see in the legacy code base is the extensive use of magic numbers, that is strong numbers out there. So as a layman will not understand, or a new developer will not understand what this order type 3 is about, why the order type is 3, or what it signifies or what it means. The new developer will not know. So what we can do, if we know what this code actually does or what this 3 stands for, we can straight away then and there go ahead and replace this magic number with a constant integer, constant variable, so that as the next time when a developer reads this code, then we will understand that we are checking if the order type is a bulk order, then do applying this discount. So this is pretty clear. This particular piece of code is pretty clear compared to this particular piece of code. And then last but not the least, this is the most important part, to add test cases before refactoring, as we have mentioned before. So it's always important to add valid test scenarios or test cases, so that you have adequate coverage, and if you do some mistake by default, by accidentally also, this test case will save you, and this particular piece of code will not go to the production line. So that's some of the examples that I want to cover. Let's go back to the PPT. So what we can do is we have to rename variables to get more clarity, and extract methods to reduce complexity and remove duplication, and make one change at a time and test. These are the scenarios that we have seen now with examples, with solid examples. The other thing that we can use is we can use some tools which will help us, which will not completely help us, but it will definitely help us to understand the behavior of the code and try to identify some bottlenecks associated with that legacy code. Some of the IDE feature like rider, VS, IntelliJ will help us to understand, help us in the process of understanding the code. There are more static analyzers which are out there like SonarLint and Roslyn, which will actually help us to point out some flags or warnings in our code, or bad code practices that are went into our code base. So static analyzer will go through or parse our code and highlight the flag those code blocks where the coding rules are violated. So this is pretty powerful. Static analyzer is pretty powerful tool, and you can use version control to see what changes went in at what point in time. Version control is a pretty helpful tool in that sense, and introduce automated test cases like using NUnit and whatever framework which are out there to cover your code adequately. Then, as I mentioned before, refactor when the code is stable and working. So it's not that we have to go ahead and refactor when something is broken. So it is better to refactor when the code is very stable and it's working perfectly. Then what we can know is if the code is having adequate coverage, test coverage, if we refactor then and there, the advantage that we are getting is in the future if additional requirements comes in, it is easier for us to integrate and we will not break anything which is existing. So rewriting is risky and costly. Most of the project scenarios that I've worked with, there might not be sufficient bandwidth which is required to rewrite that particular piece of code or particular piece of module which is there. So rewriting at a very later point in time, it is very risky and it is not possible at all in a actual production scenario. So better to rewrite when you start a project. It's the best time to do it. So when you do incremental improvements to your code base, whenever you are adding a feature and don't only modify that particular piece of code where you are adding a feature, go through the code base and try to identify some code smells which are there and try to avoid their code smells and preserve the existing. Don't try to break the existing behavior. This in this case, the unit test cases or whatever test coverage that we have introduced will help you a lot in that case. So in summary, so legacy code, you have to deal with it at any point in time. If you go to any company which is there, there might be a lot of legacy code which will be there. So you can't escape from it, literally. So you have to handle it with care, with all the things that we have discussed now. You can take the help of the tools, you can take the help of the people, original authors, you can take the help of the automated tools, automated test cases which are there to understand the code and do a better job there. So write test cases before making any changes and refactor incrementally with clarity and use tools and version control for safety later point in time. So that's what I wanted to cover in this video. If you find this video helpful, please do subscribe to this channel and like this video and share this video with your friends. Thank you.